Okay, we pretend that we are now in the lesson because I'm just recording it. Okay, so we start today to talk a little bit about exponents and powers, and I know that you have already seen that before, but let us put it in a little bit more firmer ground. Yes, so exponents. Exponents. We want to talk about this. Okay, so let us see how much you know about exponents. So you know about powers, yes?
Yes.
For example, you know 2 to power 3. What does it mean? What does it mean? It means 2 times 2 times 2, yes? And actually, the power notation or the exponent was invented in the first place because of having a shorthand notation for long numbers. For example, I don't know, in physics, people have measured, for example, the speed of light. And the speed of light, usually in physics, we measure every speed in meters per second. And we had this, usually in physics, we denote it by little c, and then we have this number. Yes. Meters per second. Okay. So, of course, you can stick around and work with this number all the time. But writing this all the time would be annoying at the end, yes? Do you have questions?
No, I was going to say how to write it easier.
That's another question. So this is 300 million meters per second, yes? Do you mean this?
Right.
Yeah, like where it was using
No, I haven't used the power yet. I'm just motivating you why mathematicians have started thinking about powers. Yes? Because we were facing big numbers on one extreme and very small numbers on the other extreme. If I remember something like that. So for example, the mass of electron is something like this.
I think it's sexism, really.
I don't know. So you have around 30 zeros. Yes, this is the mass of electron in kilogram. Yes.
Can't you write?
Louder, please.
Can't you write 3 times?
Yes. I am motivating you.
The amount of
I am starting everything from scratch. I am telling you why mathematicians got interested to this exponential notation in the first place. Yes? What I'm saying is that if you don't find a way to work with these very, very small numbers or very big numbers like that, what you have to do if they appear in the calculations? You have to write these numbers all over again, and this is really annoying. Yes, is that understandable? Now, let us say what we can do, we can invent a symbol or a notation to write these big numbers or small numbers very compactly. That is the first motivation behind him, because you know that in mathematics usually you can compare it with a game of chess. Nobody tells why bishop moves this way and the rook moves like that. The point is that if you follow the rules, that would be the game of chess. That's it. Okay? But in mathematics, the goal of game chess is probably to enjoy and kill some time. Okay? But the point of mathematics is to solve some problem in the real life. Okay? So the motivation usually, in the beginning at least, it was coming from physics point of view or chemistry point of view. So physicists were facing this number, which is in the world of mathematics on one hand, because that's a number. On the other hand, it's in the world of physics because it is the speed of something in our universe, the photon of light. Yes? So the mathematicians, whenever something starts repeating itself over and over again, and it is hard to manage it, they sit down once for all and think something about it to make it shorter, make it easier, more comfortable, something like this. Okay? So the invention The invention of powers actually is coming from this, that I want to get rid of writing all those numbers, big numbers or small numbers. For example, the motivation behind that, people see that this number here, the speed of light, for example, can be written in this way. 3 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, 7, 8. Of course, this is not something that they didn't know. They knew about this. But then realized that a number is being multiplied by itself a number of times. Okay, so let us invent a notation to make it shorter. So they said that let us write it in this way. 3 is 3, but I see that 10 is being repeatedly multiplied into itself. How many times? 8 times. And let me put this 8 here. Might be, I don't know, if the first mathematician have put 8 here, we were still following that person, you know? So this is just a matter of notation. The first person actually chose to put 8 on top here, on the right corner, not on the left corner. But that is not a very big deal. We get used to this and we continue. As far as it is good, why not? Why we should change it and here? Yeah, we just continue with that. But at least this is the real reason that we were trying to write this product in a more compact way. So we invented the power notation or exponential notation. Okay? So now I am telling you that, but there is a weakness to this definition. That is mathematics. I want to teach you that. So if I give you a number A, which is a real number. By the way, do you know the real number? What the real number is? What is a real number? Yes? What's a real number?
I think it's a number that. Well, I don't know the actual definition.
No, there is no definition.
It's irrational.
No, every number that you can imagine, except what is called complex numbers. If you don't know about that, forget about it. And if you know it, put it aside. Any number left is called a real number. Any type of number containing a square root, containing decimals, fractions, whatever you can imagine, yes, that's a real number. So if you have a real number, and then the set of real numbers for natural reasons is denoted by R because of real, and then I told you that either in the books you see it with bold R, or as I do it, most of the mathematics books write it in this way. So when I put a vertical line next to R, it doesn't mean I or something. It means the set of real numbers. Okay? If A is a real number, instead of writing is, we can write this. Okay? So this means belongs to. So I really emphasize to learn these symbols because they are so ubiquitous in mathematics that it's better to know them. So I am telling you, so how do you read this? If you want to be really precise, you need to read it in this way. A belongs to the set of real numbers. But equivalently, I can read it A is a real number. Yes, A belongs to the set of real numbers. It means that A is one of the elements of this big set that I call it the set of real numbers. So I can say that A is a real number as simple as that. So I use this interchangeably, but the real way of reading it is A belongs to the set of real numbers. Okay, now, so let me write here for you definition. So let A be a real, I emphasize on this word, and I put a line here because in English this is an article A, but this I mean a number, so I underline it so that you understand this is not an English article. This is let A be a real number and let me write N again, let me underline that, be a natural number. Then the nth power of A is denoted by A to the nth. Read it like this: A to the nth. If you write it in English, is denoted by this, and it is defined as follows. Okay? We say that if you see this symbol somewhere in a mathematics book, it means A multiplied by A multiplied by A continues multiplied by A. How many times? N times. Okay? So that is the formal definition of this. You see, in mathematics, you need to learn this way of thinking, because some people think that in mathematics we shouldn't write English sentences or Swedish sentences. No, that's wrong. I can bring you articles written by mathematicians. You see that they write a lot of words and, of course, a lot of formulas simultaneously. It doesn't mean that I am not allowed to use words. I have to write everything in symbols. No. So, there are two things that I want to emphasize. First of all, if you want to be very pedantic, it's not that correct if n is equal to 1. Because when I say n is a natural number, in American school, we start from 1. So the first n. Do you think that this sentence makes sense if n is 1? This means a to the first is equal to what? A multiplied by itself one time. You see, it doesn't make that much sense. So if you want to make it really good, you should say that is equal to A itself if n is 1, or if n is greater than or equal to 2. Yes? So, I am telling you that if A is to the first power, it is equal to A itself. If n is a natural number greater than or equal to 2, just multiply A by itself n number of times. This is a better way of defining if you want to be very precise. Okay? So, this is very easy. So far, there is no concept, there is no something very hard going on. That is just a mere compact notation for writing these long expressions. I just write compactly like this. Okay? For example, if I ask you, do you think that this makes sense? 2 to the power of 3. Does this make sense? Yes. Why? Be careful. This number, by the way, let me give you the names. This number is called the base. This number is called the exponent. And the whole package is called an exponential. Or a power. So these words you need to know. Okay, so far I do not have any restrictions on A, the base. The base can be any number that you like. But the exponent is not every number that you like. Is a natural number, but any natural number that you like. Not any number. Be careful. Do you think that it makes sense? If I write a to the power of -3, I want you to feel it. Probably you know what is a to the power of -3. But there is a big difference. I cannot teach you this and in the exam I ask you, just teach you this and in the exam ask you to calculate a to the power of -3. Because this means a multiplied by itself -3 times. Which is meaningless, yes? So be careful. If I am telling you this, this number can be any number that you like, but for the time being, we have to restrict ourselves to the natural powers, because if n is not a natural, this way of defining doesn't make sense. For example, do you think that this makes sense? If you put this in your calculator, you definitely get an answer. But this way of definition is meaningless. Does it mean 2 multiplied by itself 1 over 3 times? Which doesn't make sense. So do you understand? If someone asks you what is a to the power n, this definition only works if n is a natural number. Then you don't have any problems with that. If I ask you to calculate this, you can do it 2 multiplied by 2 multiplied by 2, and then you answer this. What's the answer? 8. What do you think about this number? For example, 5 over 3 to the power of 2. If I ask you what is this combination, what is the name of the whole combination, just repeat that. What is that?
Power.
A power or an exponential. Now I ask you, do you have questions?
Yeah. What was the difference between a real and a natural number?
Natural number is a whole number, positive whole number. Of course, every natural number is also a real number, but not the other way around. Okay? For example, 1 over 0.5. 0.5 is a real number, but it is not a natural number. But 3 is both a natural number and a real number. So it is like this, you know, you have a bag, a smaller bag, we call it a set of natural numbers. If you make it a little bit bigger, it becomes the set of integers. You include negative ones as well. If you increase it a little bit, this becomes the set of rational numbers, and people show it by Q. And if I increase it a little bit more, containing all those numbers, then this becomes the set of real numbers. So it means that whatever is in N is automatically in Z, is automatically in Q, is automatically in R. But some numbers are in R but not in Z, some not in Q. Some numbers are in Q but not in Z, and the other way around. Yes? Is that understandable? Yeah. Okay, so now I ask you, what is the whole package? What is the name of the whole package? The whole name is an exponential or a power. Now if I ask you what is the base, what's the answer? 5 over 3 is the base. Is it acceptable? Is it an acceptable base? Yes. Because base can be any real number. Yes? So it is acceptable. So what is the exponent? It is 2. Is it acceptable? Yes, because it's a natural number for the time being. Yes? And then if someone asks you what is this, you don't need to be worried because you know the definition. You have a real number raised to power 2, and then you want to calculate it. It means that write the same number multiplied by itself how many times? 2 times. And then you know how to do it, hopefully. This is just the product of fractions. 5 times 5 is 25, and 3 times 3 is 9. Yes? For example, if I give you this, 4 to the power of 4 to the power of 3 plus minus 2 to the power of 2. And by the way, let me first work with this one. Is this acceptable? Yes, because the base is negative 2, no worries. For the base, I do not have any limitation at all. But for the power, I need to have a positive power, natural positive number, which is correct. So how should I write it? I need to write minus 2 multiplied by minus 2. If you want, you can remove the brackets, not necessary. Multiply by the same number. But if you need to multiply that, minus 2 times minus 2 is positive 4. Positive 4 times minus 2 is minus 8. Yes? So you really don't... And what, by the way, what is this one? Do you think that would be the same?
No.
No.
The answer is the same, actually.
Yes.
But the intermediate step is not the same. So what is the difference between this and that? Yes?
Isn't it minus 2 times 2 times 2, something like this?
Yes.
Yeah.
So this means that, be careful, this means that this is, if I ask you, let me ask you something. If I ask you, tell me what is the base in this case, what is the base?
Minus 2.
Just tell it, minus 2. What is the exponent? 3. Here, what is the base? No, the base is 2. Let me see. The base is 2. The exponent is 3. After this is calculated, minus sign is multiplied to the result. That is the meaning. Okay? Of course, the final answer would be the same, but the interpretations are not the same. And it is very, very important to have the right interpretation, even if the answers are the same. I want you to understand that. So if I ask you to write this, if I ask you to expand this and solve the problem, you have to write it in this way. But if I ask you to expand this, you need to write it in this way. 2 times 2 times 2. If after calculating this, I put a minus sign here. But of course, we really don't need to put this pair of brackets. So you see, this is different from that, but the answer is the same. Is that understandable?
Yes.
Yes.
Okay. But if I go to this scenario, let us see what happens here. Minus 2 to the 4 means minus 2 multiplied by minus 2 multiplied by minus 2 multiplied by minus 2. The answer is 16. Positive 16. Minus 2 times minus 2, positive 4. Positive 4 times minus 2, minus 8 times minus 2 is positive 16. But here, this means that 2 times 2 times 2 times 2, 4 times because of this, and then I have a negative sign next to it. So now if I answer this, what's the answer? Negative 16, and they are not equal. Okay? So I want you to understand these differences yourself. You really don't need a teacher to understand. If you forget in the exam, you just a little bit think and then understand what's happening. If you respect the ways that you actually start writing these things. Okay? Is that understandable? Okay. So now, for example, do you think that in principle we have a problem calculating this? 4 to the power of 3. Yeah, let me make it 3. Plus 3 to the power of 4. So, do I really need an extra rule to be able to solve this or not? No. Might be, if I have some extra rule, I can solve it simpler. But I really don't need an extra rule to answer this question. Why? Because I interpret this in this way. I see that this is a addition. This is one number. This is another number. I am adding two numbers. So for addition, I don't need any new rule. I already know how to add two numbers. What I learn is just how to calculate these things. So what has the priority? So here I have to calculate this part. So what is the answer to this part? It's 4 times 4 times 4, which is 64. And then how should I calculate this? This is 3 times 3 times 3 times 3, which is 81. So I put equality in front. Instead of the first package, I put 64 simply, plus this one, 81. And the answer would be 145. Yes? So you see that you don't need an extra rule. So you can solve this problem because you respect the definition. But one thing that you need to be careful, assume that you don't have your knowledge from primary school with you, okay, from Grundschule. If I ask you, if I define this for you and ask you calculate this number, you should refuse to do that. You should understand something peculiar is going on, yes? Because I told you how to calculate when the exponent is natural number. And if I tell you this and I ask you to calculate this, you need to actually complain. Yes, it is not possible to use the same definition to calculate that. Okay, now I want to refresh your memory. Do you know how to calculate that or not? Have you seen that? Yes. 2 to the power of minus 3. Okay. So, now this is the definition. This symbol is the name mathematicians assign to this number. Okay? So when you see 2 to the power negative number, the mathematicians in mathematics books, it is used as a shortcut for this expression. Yes? So that's it. So if you see this, That's just a symbol that you need to know the rule to translate it exactly like the keyboard. For example, you know that what keyboard is used for somewhat, yes? So this symbol is used for this number in mathematics. And can I continue with this one? Yes. Why? Because if you tell me what is this, I would say this is a fraction, its numerator is 1. Do I know the denominator? Do I know the denominator?
Yes.
What is that? 8, because I calculated it already. So this is 1 over 8. So you see, if you see this in the books, they mean this expression. And then you know how to continue from this step forward, because now this is a positive natural number. Yes? Yes?
So you just put a 1 over it and take out the negative.
Yes. So that is the meaning of that symbol if you see. So in principle, if I want to define a negative number, the exponent with a negative number, so we say that this you need to know. If A is a real number, but there should be an exception, I will tell to you later. If I have this scenario, if I have this situation, a to the power of minus n, if n also belongs to the set of integers. I hope that you are not freaked out with this symbol. This means a is a real number, n is a natural number. A to the power of minus n is equal to 1 divided by a to the power of n. Okay? So that is the thing that you need to know. If you see this symbol is a little bit shorter way of writing this. Okay? So for example, if I ask you what is 3 minus 4. I want to know what is the meaning of this symbol. What is the meaning? This means 1 over 3 to the power of 4. And if I ask you what is this number, it is better not to stop here, even though that's correct. It's better to continue. Continue means what? For 1, I cannot do anything. It's already in its simplest possible form. But 3 to the power of 4 is also sitting for something else, which is 81. If you cannot calculate it directly in your head, you should write it 4 times, and then again be patient and write it 81. So at the end, if I ask you what is the meaning of this number is another name for this number. Yes, so that is the meaning of negative numbers. But there is an exception. In the previous case, a can be any real number, but here we have one exception. What is that exception? There is one number that a cannot be in the case of negative powers. Yes? Yes? 0? Yes. 0 cannot be. Because, so be careful. Here, I will emphasize that a is not 0. Okay, let me see why. If I ask you calculate 0 to power minus 3, what is the meaning? It becomes 1 over 0 to power 3. But 0 to power 3 means 0 times 0 times 0, which is 0. But 1 divided by 0 is undefined. Yes, division by 0 is forbidden. So, when you have a negative power, it is extremely important to be careful that a cannot be equal to 0. So, I have seen some students say that they remember it in this way. 0 to any power is 0, but this is wrong.
No, it's 1.
0 to any power is 0, yes? So 0 to power 3 is?
No.
0 to power 3?
0.
Why? Because this is 0 times 0 times 0 is 0. 0 to power 7 is 0 times 0 times 0 times 0 times 0, 0. But if you just want naively say 0 to power minus 3 is also 0, because 0 to any power is 0, that is wrong. Yes? 0 to power negative 3, if you calculate using your calculator, you definitely get undefined. So 0 to power minus 3 is not a number. It's not defined. It's not a real number. So be careful about these exceptions. So we just learned about negative powers, and I want to stop here because today I wanted to teach with for nearly 1 hour and then let you to practice on the exercises in the book. But from the beginning I start talking a lot, solving a lot of problems. Okay, so I will stop here. Now next time, is it tomorrow? Yes. So next time, tomorrow, we will start continuing this lesson. And then, of course, I will upload everything on YouTube and Google Classroom, and I tell you which parts if it's better to study. Thank you.
I have a question.
Yes, please.
On the